Hi everyone. This is the first video in the scope of the API testing course. The course is oriented towards manual testers, but can be useful for anyone interested in the subject. In this video, we are going to talk about the API with analogies and visualization in plain English. Let's begin. We'll start with Wikipedia. Don't worry, the video won't be too boring. As we said, the API is a complex term and we need to start from somewhere. And this definition is simple and good. The part we're interested in are these two sentences. An application programming interface, API, is a connection between computers or between computer programs. It is a type of software interface that offers a service to other pieces of software. Sounds straightforward, but at the same time, not clear at all. Let's start simple. The API is an acronym and we are going to learn the meaning of each word individually. Let's start with letters A and P, which stand for an application programming. An application program is another complex term. We can check Wikipedia again, but this time we won't, as we promised plain English. And we want to learn what is API to be able to test those effectively, not to write a novel about it. And in plain English, the word is an app. This word is familiar to all of us, but everyone understands this in their own way. As part of this course, we propose the following definition. An app is a computer program designed to help people perform an activity. There are two words we need to pay additional attention to in the scope of this definition. The first word is people, better to say the end users. This is simple. It is you who use the app to watch the video and us who use the app to create it. And we can access apps on laptops, tablets, or phones. The second word is an activity. And the question we need to answer is, with what kind of activities apps can help us? The short answer is, any of them. If you want to search on the internet, you use the browser. If you want to watch a movie or listen to a song, streaming apps. If you want to message someone, express yourself, or even become popular, social media apps are your choice. It is only 3 examples of apps. We use those every day. What we forget about is what is the app in deep and what is hidden under these nice pictures. In plain English, application or app is lines and lines of code. This is an example of the smallest and simplest app in different languages. Real apps have thousands of lines of complex code. As manual testers, we don't need to dive too deep into this for now. Even if you don't know any programming languages, you will still be able to test the API. It will be manual functional testing from the end-user perspective. You can drive the car even if you don't know what is hidden inside. Similar is here. The first part of the course will be manual testing. The second part of the course will be the automation of the things we tested manually. And the beauty of it is that all of you will be able to finish it. For those who know a programming language, it will be easy. For those who don't, it will be also interesting. Let's continue our journey. To summarize, application programming is short in an app. An app is a computer program designed to help people perform an activity. For any activity, we have an icon on our smartphone. And under those icons are hidden thousands of lines of code. We have discovered the first 2 letters from the API acronym, A and P, which stand for application programming. Let's move to the letter I, which stands for the interface. The word interface is one of those where you think you know what it is, but you can't explain it. It is an extensive and abstract term. Let's check the definition of it. An interface, the place at which independent and often unrelated systems meet, interact, or communicate with each other. Be prepared for the most boring minute in this video. We'll draw the abstract schema for the abstract term. So let's start. First of all, we have 2 independent unrelated systems. Just 2 circles for now. Second, we have the interface itself. What is important here, the interface is not an independent piece. It's a part of one of the systems. In our case, system number 2. System number 1 wants to connect to system number 2. Because of this, system number 2 has the interface. Systems interact or communicate through the interface. That's all, schema is done. For now, it is very confusing. It is very popular to explain API terms by comparing them with a waiter, a socket, or a librarian. Let us show our version of the explanation of the API concepts based on the waiter example as well. It is the best example for our opinion. We'll start not with a waiter, but with a customer. A customer is a system number 1, and we'll start to call this system a client system. As we said before, system number 1 wants to connect with system number 2. And the main characteristic of the client system is that it has a need. The need is the reason for the system's communication. In this case, the customer is hungry and has a need for deliciously prepared food. We'll change the name of the system number 2 to the service system. Respectively to the name, the main characteristic of this system is that it provides service, which meets the needs of our client system. In this case, service is to prepare and serve food. The service system is a restaurant. It's a complex system that consists of lots of components. A chef who prepares food. A manager who's got a lot of different duties and responsibilities. And the interface. A waiter. Let's check how the end-to-end communication flow happens between the client system as a customer and the service system as the restaurant. You come to the restaurant and sit by the table and ask for the menu. The waiter provides you with the menu. You get familiar with it and place the order. The waiter serves prepared food back to you. You eat it, pay for it, and leave. There are a couple of things we need to highlight which will be important in a minute when we'll talk about the API. First, the interfaces are part of the service system, like a waiter is an employee of the restaurant, and all of the interactions and communication happen only through the interface. So everything inside can be kept secret and not being exposed to the clients. You can order food, but you can't check accounting documents. If you ask the waiter to show you the accounting documents, he won't share this with you. Even more, most likely he doesn't have access to that information. Second, the word unrelated. Unrelated systems. You as a customer are a human. A restaurant is a building, legal entity, or organization. It is a system, but totally different from you. So, restaurant needs an interface understandable for the clients. You want to be able to talk with the building. You need something you can understand to communicate with, and in our case, it is another human, a waiter. The interfaces are designed the way client systems are familiar and able to communicate. Third, you as a client do not need to care about how the restaurant works inside, who delivers the food to the restaurant, who manages it, and how the food is cooked. You do not need to know the answers to these questions to fulfill your need. All interactions and communication happen with the waiter. We know what you think. All of this is very interesting, but it is too far from the API. It is too plain in English. So, it is time to move to the programming world of the zeros and ones and check how the theory applies here. Let us remind you what an API is, according to Wikipedia. An API is a connection between computer programs that offers a service to other pieces of software. And we talked about how in computer programming everything is a code. Instead of a customer we have a code, and instead of a restaurant we have a code, and the interface is a code. We do not understand this, but apps do understand. APIs are interfaces for the apps, where one app connects to another app, not for humans. Because of that, we will need a high level of abstraction. Understandable for humans testers, humans. Let's make our schema more user-friendly. it is common to compare the API to the socket, and we will do exactly the same. We agreed that we know that apps are lines and lines of code. But for us end users, an app is a computer program designed to help people perform an activity. For any activity, we have an icon on our smartphone. Because of that, we'll put those icons in the client and service app circles, from the end user's perspective. Speaking about the end users, we need to add those to our schema. Even more, we need to make the schema a little bit more complex and add another interface. If you want to text someone, you pick up your smartphone, find the icon on the app you need, type your message and send it. For all of that, you need a smartphone with a graphical user interface. You don't connect with apps directly, you simply can't, because humans and apps are unrelated systems. The same as you can't talk to the restaurant as a building, you need a waiter as an interface. Same here, all your interactions happen with the interface, graphical user interface. This is easy to understand because we do it every day. In contrast to a user interface, an application programming interface connects apps to each other. The API is not intended to be used directly by a person, and that's why it is hard to understand this and it needs clarification. The clue here is the definition of the app is a computer program designed to help people perform an activity. Sometimes the app can't fulfill the needs the end users have, and they ask another app to help. And this communication is not visible to you on GUI. It is time to check a couple of examples of the API which you have seen or used as an end user. Let's keep it simple and start from scratch. First app is Google Maps. It's a very popular API, and Google Maps has a lot of features to help people perform activities. Find the best route when driving from work to home. Check reviews and feedback on the places you want to visit. And the features we are most interested in, the scope of this example. To find the closest restaurant if you're hungry. We will put this feature in the circle with an icon of a nice cup of coffee. If you're hungry and want to find the closest restaurant, you can take a laptop and search for it on Google. With a laptop with a nice GUI, this particular feature is accessible to you. Search for the restaurant is an activity, and the app helps you perform it. All of this is according to our schema and definitions so far. The question here is how the other app is involved. So let's find the answer to it. The second app in our schema is the McDonald's app, which has its own end users, and they also can access it with the GUI on their smartphones. Again, according to our definition, an app should help people perform an activity. And the main feature of the McDonald's app is that you, as an end user, can order the food and pay for it. Instead, standing in the line, you can just use an app and even have some exclusive deals or bonuses. This is the main benefit of it, but not the only one. There is another innocent feature. Before you place the order, you need to know where the closest restaurant is and where exactly you will need to go to pick up your food. This is exactly the same feature as we discussed with Google Maps. Here, you also can find the closest restaurant. The difference is that on Google you can find different kinds of restaurants, and McDonald's needs to show only their own restaurants. But everything else is exactly the same. And it drives us to the most important benefit of the APIs. McDonald's has two options. The first option is to build this feature by themselves, and in the end, they will develop exactly the same functionality with Google Maps already have. And this will cost a lot of money and it will take a lot of time. The second option is that they will collaborate with Google Maps. McDonald's not only will save money and developers time, but customers and users also benefit from interacting with one of the best mapping applications ever made. Even more, they are likely already familiar with it. because sometimes users can be the same. You can use Google Maps and you can use McDonald's app. For you, it will be easier to see exactly the same map in the McDonald's app. You will already know how to use it. And we face the problem here. Google Maps has the feature McDonald's is interested in, but how it can share it? Google doesn't want to give its code, database, or data to another company. They want to provide limited access to all of that. And to do it in a simple way, because of that, they need to build and develop the API. We finally came to the point of the reason why APIs exist and what is the benefits of them. Let us remind you where we started. The definition of the API in Wikipedia. An API is a type of software interface that offers a service to other pieces of software. Google Maps are the service app because they provide a service. The service is their feature to find the closest restaurant, and they provide this service to McDonald's, another app. And to provide the service, Google Maps uses the API. Let's check first a simple scenario of how it will work. It won't be visible to you as the end user at first. Each time when you open McDonald's app, the app will check your location and will send the geocode to the Google Maps servers. Google Maps will accept this code. They will know that they received the request from the McDonald's app. Their code will do their magic and generate the map based on the received geocode. Then they will send the generated map back and it will be visible on your phone. You as the end user will see only the McDonald's restaurants in the McDonald's app, but on the map generated by Google Maps. Now, we can talk about the benefits of this approach for both apps. McDonald's as a client and Google Maps as a service. McDonald's don't need to know anything about Google Maps, what language they are written, and what architecture do they have. Instead of wasting a lot of time and money to write the map feature on its own, McDonald's needs to write a small piece of code to send the geocode and integrate the map into their GUI. Google Maps will receive money for each time McDonald's calls their API. Google Maps can sell the same API to other companies like Starbucks, Subway, KFC, and generate even more money. Google Maps don't need to expose anything they don't want to with clients. Database, the code, architecture, everything is hidden. Clients have very limited access to their system. Another important thing to mention is unrelated systems. Google Maps can be written in Java and McDonald's can be developed in Python. For the API, it is not a problem because mostly it is based on the data. Geocode is a string and a map can be just an image. This is all in plain English and we know there are a lot of not clear things. We will learn this much better in the next video, based on client-server architecture and RESTful APIs. But for now, from the point of the end user, we think it's clear. Let's check more examples where you have seen and used APIs. The same feature we just discussed, but on the McDonald's website. As the end user, you can see that the map is from the Google Maps API because UI is exactly the same. One more good example of public APIs is the social login feature. You as the end user, instead of creating a new account specifically for that website, you can use an existing account on Facebook, Twitter, or Google and sign in. For example, when you click on the Continue with Facebook button, eBay calls the Facebook API. Another example of public APIs is the Share button, all over the internet, often used in one social media to share in another social media. When you share news, videos, or pictures with friends, it is done with the help of APIs. We think you already got the concept, but the last example which we want to show is the Pay buttons. When you purchase online, you can do it only with help of the APIs. Those are everywhere. In fact, nearly every time when you click a button, the API is in use. and that's why it is important to learn how to test it. And we will learn it in the next videos. This video was long probably, but you notice that we haven't done that much. We have got familiar only with two definitions, the app and the API, generated schema for those, and checked how the schema works on the examples on the public APIs. All of that we did in plain English manner from the end user perspective. But plain English is not the best way to learn these concepts, of course. The schema is simplified too much. Our next step is to dive deep into the API's world, learn the client-server architecture, the difference between public and private APIs, and what makes API RESTful. So, if the video was useful for you, please subscribe, put the thumbs up or comment. See you in the next videos. Wish you all the best and be well.